Functions are monomial expressions whose variable is raised to any exponent. It can be a fraction as long as it is a real number. It can be a fraction, it can be a decimal, it can be negative, it can be positive. In the polynomial function, the exponents of x could only be positive. In the power function, it doesn't matter as long as it is a real number. So how do we find its inverse? So we follow the same procedure. Y is equivalent to 3x raised to 2/3. And then switch x and y, 3y raised to 2/3. Then after that, we need to isolate y, so we don't need this 3. We will divide it to both sides of the equation. And so you will have now x over 3 is equal to y raised to 2/3. But the exponent of y could only be 1 for it to be equivalent to f of x. And so what we can do is to multiply this exponent to its reciprocal, which is 3 over 2. But whenever you do it to the right side of the equation, you should also do it to the left side. And so this cancelled because it is equivalent to 1. And so therefore, our inverse function is equivalent to x over 3 raised to 3 over 2. Expression instead. So this is still a power function because if I'm going to put this in the exponential form, this is x raised to 1/3. Now, how do we find its inverse? Of course, we follow the procedure y equals 2x raised to 1/3. Then, of course, we switch x and y like that. And now, we don't need 2 here, so we will divide by 2. And so you have x over 2 is equal to y raised to 1/3. And because we would like our exponent for y equal to 1 only, we will raise the whole equation by 3. And so therefore, okay, because that 3 is the reciprocal of 1/3. And so therefore, x over 2 now, our inverse function, is x over 2 raised to 3. Or you can simplify it further to be x cubed over 8 because 2 raised to 3 is equivalent to 8. So let's do another power function. F of x equals negative 5 x raised to 3/4. Okay, so put it first in the y form and then switch your x and y. And then isolate y, so we don't need negative 5, so we will divide both sides of the equation by negative 5. So x over 5 now becomes negative, and you have y raised to 3/4. But I want y raised to the first power. So we will raise the whole equation by the reciprocal of the exponent of y, which is 4/3. So making this equivalent to 1. So therefore, I will have, okay, I will have now y is equivalent to negative of x over 5 raised to 4/3. So this would be enough as the inverse of the power function. Just put it in f raised to negative 1, okay, equals negative x over 5 raised to 4 over 3 equals 2x raised to 2/3 plus 1. So first step, y equals 2x raised to 2/3 plus 1. Second step, switch x and y to y raised to 2/3 plus 1. And of course, I'd like to isolate y. I don't need positive 1 here. So this now becomes x minus 1 equals 2y raised to 2/3. Then of course, we will divide by 2. Both sides of the equation. And so you will have now y raised to 2/3. I can do symmetry so that you can see more clearly. Okay, now, what happens here is we just have to raise the whole function to 3 over 2, 3 over 2. So therefore, our inverse function, f raised to negative 1x, is equal to x minus 1 over 2 raised to 3 over 2. actually show that it's really the case by means of graphing it in a Desmos graphing calculator. These are your two functions, 2x raised to 2/3 plus 1 and x minus 1 over 2 raised to 3 over 2. As you can see, you would see that they are symmetrical to the line y equals x. So this is the line of symmetry y equals x. They will surely intersect at a certain point. Now, there is supposed to be a restriction of the domain here. Our x here is greater than or equal to 0. So if I'm going to put a restriction here, okay, it will show you the proper way of doing things. So x is supposed to be greater than or equal to 0. X is greater than or equal to 0. And then you have that. And you can see more clearly the inverse function itself. So it means that if you're asked what will be the domain of the inverse function, you would say that the domain of the inverse function is x is greater than or equal to 0 for the inverse to become 1 to 1.